Okay, we're back. This is Math 200. We're looking at Chapter 7. We're going to do 7.2 on the note packet. So open up your packets all the way to page 4. So what we're doing here is we're adding up fractions where there is a common denominator already. So 4p minus 3 over 2p plus 7 plus 3p plus 8 over 2p plus 7. So since the denominator is already common, what we can do is write it as 2p plus 7. That's an arrow, not an equal sign, because it's in the expression. So we're not doing equations yet. We're going to work equations in 7.5, but right now it's just expressions, so we're just adding these two fractions together. When we have common denominators, you write it down once, and then you put the top, the numerator, plus the numerator. And now the algebra part is combining like terms, and then looking to see if you can reduce. So 4p plus 3p is 7p. Negative 3 and positive 8 is positive 5 over 2p plus 7. Nothing can be factored out, nothing can be canceled. That's it. Number 2, 8y over y minus 2 minus 16 over y minus 2. So again, we write the y minus 2 once, and then we have 8y minus 16. Those are in like terms, you can't do anything with it, but what you can do is factor out an 8. So if I factor out an 8, I pull an 8 out, I undistribute an 8, and then I divide that by 8 and get y, I divide that by 8 and get 2, and the minus stays there. But now look, we've got 8 times quantity y minus 2 over y minus 2, or kind of like 1 times quantity y minus 2. So those y minus 2's can cancel, and that's 8 over 1, or just plain old 8. All right, let's keep going. What about if I have y over y squared plus 3y minus 10 minus 6 over y squared plus 3y minus 10. So again, we write down y squared plus 3y minus 10 over 3y minus 6, and we're going to want to factor both of these. So on this top, I can factor out a 3. Divide that by 3, divide that by 3, get y minus 2. On the bottom, we look for suspects for negative 10, but we really want to look at this one. We want one of them to be minus 2. So that's going to be my very first suspect, negative 2 and 5. That happens to multiply to be negative 10 and adds up to be 3. So that is who done it. So we've got y minus 2 and y plus 5. And now you have 3 times quantity y minus 2, y minus 2 times quantity y plus 5. Those y minus 2's cancel. You just have 3 over y plus 5. Again, if you'd like, you can leave the parentheses on there, or you can leave them off like I did on that one. It's fine. With or without parentheses. You want those parentheses on there, you go right ahead and put them on. All right. Okay. Find the LCD. So they don't want me to actually add or subtract these. They just want me to find the lowest common denominator. And so eventually we will be adding and subtracting like what we did here. But for right now, on the bottom of page 5 here, they just want me to find the lowest common denominator. So 1 over 6y and 3x over 4x plus 12. So to find the LCD, we're going to break these down into their smallest pieces. So 2 times 3 times y. 4x plus 12, I'm going to factor a 4 out of there and get x plus 3, but 4 times x plus 3 can still be broken down further to 2 times 2 times x plus 3. All right, so we take that 4 down to its base components. And now the LCD, what we're after, first you take anything they have in common. So see, they both have a 2, so that's common. So write that down. Nothing else matches anywhere, so then you take all the rest of it. So you take this one times 2, you take that one times 3, you take that one times y, and you take the binomial times x plus 3. And so the lowest common denominator between 4x plus 12 and 6y is 12y times quantity x plus 3. That is the LCD. All right. Well, let's take a look at 2. 4 over x squared plus 4x plus 3, and 4x minus 2 over x squared plus 10x plus 21. Again, we're not adding these or subtracting them. We're just finding LCDs. So you can kind of ignore the numerators on these. We don't need to work those at all. We're only focused on the denominators. So multiplies to be 3, adds to be 4. Well, there's only one set of suspects for 3, 1 and 3. So that is x plus 1, x plus 3. Multiplies to be 21, adds up to be 10. So things that multiply to be 21, that is 1 and 21, or 3 and 7. It is 3 and 7. All right, so we have those factored. So now let's write them as factored numbers here. X plus 3 and x plus 3, x plus 7, and we'll find the LCD. So what do they have in common? Well, they both have an x plus 3, so you take that once, and then you take the leftovers, that one and that one. And that, you know, binomial times binomial times binomial is my lowest common denominator. I know it doesn't seem like a lowest common denominator, it's very abstract, but it is. That is the LCD. All right. Okay, let's look at 3 and 4. So we're finding LCDs. We break them down into their prime pieces, their binomials, and then we see what they have in common and take it, and then take all the leftovers. So number 3, we have 3x over 5x squared minus 5, and we have 4x squared over x squared minus 2x plus 1. So this we factor out of 5, we get x squared minus 1, and then we can factor x squared minus 1 again. That is perfect square minus perfect square. So the difference of two perfect squares, x plus 1, x minus 1. So that's, this first one is 5. So x plus 1 times x minus 1. That is its prime factorization. Same thing here. Multiplies to be positive 1, but adds to be negative 2. Again, only one suspect there, negative 1 and negative 1. So x minus 1, x minus 1. All right, so the LCD, how do I find that? Well, first I take what they have in common. They got an x minus 1, and then I take the leftovers. I take the 5, I take the x plus 1, and I do take the other x minus 1, even though we already have it there, but we put it down again because it was a leftover. All right, that's my LCD for that one. And then number 4, this one is really, they give our LCD. So be aware, when they write it backwards, they're up to no good. Let's write it forwards. We always usually put the variable first and the number second. So when you see it reversed, a red flag should go off. There's something wrong there. That we always write the variable first and the number second, not the other way around. Okay, so now look. This is x minus 3. This is negative x plus 3. Those are exact opposites of each other. So the LCD is actually just x minus 3. We just multiply this by negative 1 top and bottom, and that would get me the negative 2 on top, but then it would be x minus 3 on bottom. So it already kind of had it ready to go. Okay, let's look at the next page, page 6. They want us to find the LCD and then add or subtract. That is page 6 and page 7. So these are a little more intense. So let's take a look at these. So they got 3 over 9y to the 5th is equal to something over 72y to the 9th. So you look at that and you say, okay, what did I multiply to get those? What did I multiply 9y to the 5th by to get to be 72? Well, that is 8, top and bottom. And then y5 to y9 is y4. And so on the bottom, I multiply by 8y to the 4th to get to 72y to the 9th. On the top, I'm going to multiply by 8y to the 4th, and it'll be 24y to the 4th. All right? So now we're going to apply this on problems. Let's say we want to add 15 over 7a plus 8 over 6a. Let's take apart 7a is just 7 times a. 6a is 2 times 3 times a. We're looking for the LCD. And so now the LCD is what they have in common. They got an a. And then leftover, leftover, leftover. So 2 times 3 times 7. So 6 times 7 is 42. 42a. That's what I want on the bottom. So we're going to kind of go on a vision quest here. We want a 42a to happen on the bottom. And now you work backwards. So make sure to write yourself a special note. What do I multiply 6a by to get 42a? That would be 7. 7 times 6a is 42a. So if I multiply that on the bottom, I have to multiply that on the top. Same for numerator and denominator. Really, I'm multiplying by 1. Remember, 1 times anything is that anything. So negative 17 times 1, negative 17. This is a fancy 1. 7 over 7 is really just 1. So what is that? 56. And this one we have to multiply by 6. And that's going to be 90. And now we can do what we did before, where we've got the 42a on the bottom once, and 90 plus 56 is just 73. Oh no, 146. I'm sorry, 146. What am I doing? 73. 146. And then we reduce 146 over 42a. We divide by 2. That's 73 over 21. There we go. So you could reduce it. So we found a common denominator, we multiplied top and bottom by the same thing, and then we reduced their fraction. And that's our answer. Okay, let's look at 2. Five over 2x minus 6 plus negative. Anytime they have a minus, I make it a plus negative, so the negative's on the 3. And again, they're up to shenanigans. Negative 2x plus 6. They have 6 minus 2x. You know they're up to no good. Write it so it's forward. Negative 2x plus 6. Okay? So now look, what would be my common denominator here? That would be just 2x minus 6. I already got it here. That stays here. I have to multiply top and bottom by negative 1. And I'll get 2x minus 6. So see, I got it there. A negative times a negative is a positive. Now I go ahead and add those together. So that is 2x minus 6 over 8. But wait, we can still do something and factor a 2 out of the bottom. We can't do anything with the x minus 3, but now that we got that 2 liberated from the binomial, and it's being multiplied by this, we can reduce it. All right. Okay, let's look at the next one. It is 7 over 2x minus 3 minus 3, so we're going to say plus negative 3 over 1. Common denominator between this and 1 is going to be the 2x minus 3. So that means I want to multiply the bottom by 2x minus 3 and the top by 2x minus 3. So here, it's already 2x minus 3. So I just bring the 7 down. Here, we take the negative 3 times both of those, negative 6x plus 9. And now we combine like terms. So the 3 and the 9 can go together. Negative 6x plus 16. And you can factor it, the 2 out of there, but it's not going to be the same as this. So, I mean, this is our answer. If you wanted, if you were unsure, you're like, oh, I wonder if it'll cancel, you can factor out a negative 2, if you want, out of the top, and tell me 3x minus 8 over 2x minus 3. This is also fine. You couldn't do anything with it, though. You know, it won't reduce, so either one of those is fine. All right. Let's look at the next page. These are some intense problems now. So here goes. We had 4 over x squared minus x minus 6 plus x squared plus 5x plus 6. So we bust out our sweet factoring skills. Multiplies to be negative 6, adds up to be negative 1. That would be negative 3 and positive 2, right? Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1x, right? Multiplies to be positive 6, adds up to be 5. That's going to be x plus 3, x plus 2, right? 3 times 2 is 6, 3 plus 2 is 5. So now our LCD. They have an x plus 2 in common, so we circle that, take it once. Left over, left over. Ooh, conjugates even. All right? So now, do yourself a favor, put this step in there, write these out in factored form before you start. X minus 3x plus 2, x plus 3x plus 2. Okay, so now we're going to go on our vision quest. We want this, x plus 2, x plus 3, x minus 3, x plus 2, x plus 3, x minus 3. And now you go back to your Sesame Street days. One of these things is not like the other. Look, there's 2 things there, there's 3 things here. I've got the x plus 2 taken care of. I got the x minus 3 taken care of. I don't have the x plus 3. So I need that on top and bottom. And then you distribute the 4 there, you get 4x plus 12. So that's my new fraction. One of these things is not like the other. We got x plus 3, we got x plus 2. We don't have an x minus 3 on it. We need it. So x minus 3, 3x squared minus 3x. All right, and now we combine the like terms. So you write it down once. And x squared stays x squared. Minus 3x plus 4x is plus x, plus 1x if you'd like. And then plus 12. And that's prime, you can't factor it. So that's all she wrote. But that is hard enough, isn't it? All right. So that was number 4. Let's look at number 5. Okay, I'm going to need the whole board. 5. Ay, ay, ay. So again, we are building on your skills from chapter 6 and factoring. And now that I said that, check it out. We got to factor this AC method. So AC method, that's 2 times -5, gives you -10. And it has to add up to -9. So -1 and 10, -10 and 1. That'll do her. So now we're going to sneak that in here. -10x plus 1x minus 5, 2x squared. Remember, AC method. Now we do factor by grouping. We factor a 2x out of the first two. End up with x minus 5. We factor a 1 out of the second two. End up with an x minus 5. And there we have it factored. X minus 5, 2x plus 1. Now, knowing that we have this, this one can't be used for that, but we're going to guess and check this 6x squared, okay, minus x minus 2, using the thing that might work, 2x plus 1. We could get that. We can't get -2 with a 5. We can get it with a 1. So we're going to try 2x plus 1, and we're going to kind of reverse engineer the other binomial. So look, 2x times blank is 6x squared. Well, that would be 3x. 1, positive 1 times what is -2? Well, that would be -2. Now, you still have to double check the middle term. So we get 3x, and we get -4x, and when you add those together, you get -1x. So it does work. So that is factored. All right, so let's write these in factored form without all this work. 2x minus 1 over x minus 5, 2x plus 1, plus x plus 3 over 2x plus 1, 3x minus 2. All right, we have to find a common denominator between these two. So on the top one, we have x minus 5, 2x plus 1. On the second one, we have 2x plus 1 and 3x minus 2. And we want the LCD. So to find that LCD, what they have in common, they both have a 2x plus 1. And then the leftovers, x minus 5, 3x minus 2. Okay, so that is my LCD. So now we go on a vision quest for 2x plus 1, x minus 5, 3x minus 2. 2x plus 1, x minus 5, 3x minus 2. And you work backwards. So you look, there's these two things, but it's missing something. I've got that. I've got that. I don't have this. So I'm going to multiply it by 3x minus 2. And now look, we're back to chapter 5. Distributive property, 6x squared minus 4x. Distributive property, minus 3x plus 2. We're missing something. We got the 2x plus 1. We got the 3x minus 2. We don't have an x minus 5. That top and bottom. Back to chapter 5, where you multiplied things out. X squared minus 5x plus 3x minus 15. And now we've got all of them on the bottom here. 2x plus 1, x minus 5, 3x minus 2. And we're looking for like terms. 6x squared plus 1x squared is 7x squared. -7 and -2, right? -4, -3 is -7, and then -5 is what? -12, and then plus 3 is -9x. So I added up all x values all in one shot. You could do it separately, -7 and -2, also -9 if you wanted to combine them here and combine them there, and then just add those two together. Same difference. +2 and -15 is -13. And that is prime. That is the answer. And that is a really hard problem. It's a lot of steps. It's a lot of stuff to keep straight. So make sure to kind of write yourself notes about how these things are getting accomplished. All right. Let's take a look at number 6. So we got 7 over x minus 1, we got 10x over x squared minus 1, and we got plus -5 over x plus 1. So x minus 1 is already factored. X squared minus 1 becomes x plus 1, x minus 1. And x plus 1. And so LCD, we take what they have in common. So look, these are common. These are common. That's my LCD. No leftovers. So check it out. Here, I'll rewrite it. 7 over x minus 1 plus 10x over x plus 1, x minus 1 plus -5 over x plus 1. Okay? And so we're on a vision quest. This is an expression. We're trying to get it to be x plus 1, x minus 1 in the denominator. Lots of writing with these problems, okay? So we've got that LCD there, there, and there. Now we work backwards. What's missing? Well, it's got the x minus 1, but it doesn't have the x plus 1. And then we do the distributive properties, 7x plus 7. It's got both of them, so just 10x. It's got the plus 1, but not the minus 1. Okay, -5x plus 5. Combine like terms. So on the top, we got 7x plus 10x is 17, minus 5x is 12x. And then 7 plus 5 is 12. Oh, drat, we are not done. So we combine like terms. We put the 7x, the 10x, and the -5x, got 12x. We put the plus 7 and the plus 5, got 12. But now look, we can factor a 12 out. And then we can cancel on the x plus 1s. And there's our answer. Okie dokie. All right, that is it for 7.2.